the game show Deal or No Deal. Have you ever watched it? You know how it works? 25 gorgeous supermodels standing on risers, each holding a suitcase. The contestant comes out and chooses one suitcase to be her own or his own. And then the rest of the show, she's really betting whether or not she has the most money you can win. The most money you can win is $1 million. If right off the bat she picked the suitcase that had $1 million in it, then that's the most she could possibly win. She calls out numbers corresponding to briefcases, and each time she calls out a briefcase, the model opens the briefcase and shows the monetary value of what's inside the briefcase. The briefcases hold amounts between 1 penny and $1 million. And at the end, you want to be holding the $1 million suitcase. If a player, let's see, let me do one more bit of explaining just in case you haven't seen Deal or No Deal. Each time she calls out a number, the supermodel opens the briefcase, and that monetary value is now out of play. A very lucky person would pick the 1 penny, the $1, the $5, and get all of those briefcases out of play because those aren't the amount of money that you want to win. You try not to open the suitcases with big money because that's what you want to have left at the end. So if a player adopts the strategy of choosing the option of no deal, in other words, keep going until only one suitcase remains, the payoff is one of those amounts, and they're all equally likely. Find the expected value for this strategy. Now, for those of you who have watched the show, you know that when the contestant has eliminated, say, 10 of the suitcases or briefcases, a person called the banker will offer her an amount of money to quit playing. Stop now and I'll give you $500,000, or stop now and I'll give you, $200,000. The banker's trying to get her to quit before she wins the $1 million. So if she's determined not to quit, if she's going to keep going until there's only one suitcase, no matter what the banker says, how much can she expect to walk away with? Well, really, we can make a probability distribution. These are the possible outcomes from 1 penny all the way to $1 million. We're going to put that in list 1. And then I think there are 26 suitcases in all. Debbie, I just saw you counting them. Is that what you got? 26? Yeah. The probability that the one she's holding is the $1 million is 1 out of 26. So we're going to enter all the probabilities as 1 out of 26. And make sure that, well, let me go ahead and clear both lists. Make sure that you put the penny in as $0.01. The rest of the amounts are in dollars, so the penny has to be written in dollars. So if the last case she's holding, or the last model's holding is a penny, then she'll win 0.01. And I'm just going to stop talking and enter these other amounts. I can't get it where I can see everything I want to see at once. Oh no, I think I might have skipped a suitcase. Oh crap. $1 million. Might have skipped 2 suitcases because I should have 26. Miss Abby, would you read the amounts to me? And I can't get both of them. Oh, wait, where did I get? Why do I have 4? What the heck? That's supposed to be 400. Let me get back to the top of my list. Read the amounts to me after a penny. Yep. Yep. Uh-huh. Yeah. Okay. Ooh, I don't have 75,000. 50,000 and then 75,000. Okay, it really doesn't matter what order these are in. So let me put in my 75,000. And then after 75,000, there's 100,000 and then keep going. What's after 100,000? All right, I left off the 400,000. I just couldn't get all the numbers and my calculator on the screen at the same time. 400,000. All right, so I have 26 suitcases in there. I'm going to go to the top of the next list, and the probability of any one of the suitcases holding the $1 million is 1 out of 26. You can enter that as 1 divided by 26. And the calculator will change it to a decimal. Now I have to do, I don't know how to copy. I think I have to do that 26 times. Now list the 26 possible outcomes and then the probability of each outcome. I think this is giving me carpal tunnel syndrome. All right, I have the same probability for all the outcomes. Now, what do I do when the homework or test question says, find the expected value? Because what do I know that that's the same thing as? That's the same thing as the mean. So just stat, first quit stat editor, then stat, calc, one variable stats, using list 1, comma, list 2. If the contestant was just going to turn down the banker and keep going no matter what the banker offered her, what would be the expected winnings? Say to the nearest dollar. Yep, 131,478. That's not a bad haul. I wouldn't mind winning 131,000 instead of $1 million. What's the value of the standard deviation? To the nearest dollar. $253,584. Ooh, that might just give me a different take on that strategy. The expected value, or if I wasn't in a statistics class, I'd probably say the average winnings would be about 131,000-ish. But look at the standard deviation. One standard deviation below the norm, below the mean, what are you going to win? You're going to be paying Howie. You're going to, well, actually, your winnings would be 0 because Howie doesn't make you pay him. Howie has enough money. Use the range rule of thumb to find the usual outcomes. Well, you've got the minimum usual and the maximum usual. The minimum usual is the mean minus 2 standard deviations instead of negative. Just like it didn't make sense to say you would get 8.5 green pods out of 8 peas. That's not possible. It's not possible to lose money or owe money on Deal or No Deal. So the minimum usual value is 0. It wouldn't be unusual at all if you adopted that strategy and walked away with nothing. That's less than 1 standard deviation away from the norm. The maximum usual would be the mean plus 2 standard deviations. That's about 500,000 plus 100, 600 and something. Does somebody have it for me? What? 638, 646. Does anybody second that? Anybody get the same thing? Okay. So it would not be considered unusual to walk away with nothing. It would not be considered unusual to win $638,646. It would be unusual to win the million or even the 750,000. But you need to have linked in your head the words expected value and mean, because that's what expected value is. Based on the preceding results, is it unusual to win 750,000 or $1 million? Yep, because that's outside the range of usual values.